Next problem. The dimension of magnetic field in M, L, T and C, that is Coulomb, is given as. Okay, instead of ampere we are taking C as one of the fundamental dimension. Now we know that one relationship between magnetic force acting on a charge moving in a magnetic field is given by QVB. So dimension of this force will be equal to the dimension of this expression. So dimension of B will be equal to dimension of force divided by dimension of Q into V. Dimension of force is M1 L1 T minus 2. Dimension of Q is Coulomb and dimension of V is L1 T minus 1. So if we solve this, we will get, this will cancel out and we will have M1 T minus 1 C minus 1. This will be the dimension. Option C is correct. Next problem. Consider a uniform square plate of side A and mass m. The moment of inertia of its plate about an axis perpendicular to its plane and passing through one of its corners is. Okay. So if we wish to find out moment of inertia about an axis which is passing through one of the corners, in that case we need to apply parallel axis theorem. So we should know moment of inertia about an axis which is passing through center of mass. So moment of inertia about an axis passing through center of mass is ma square by 6. This is a standard expression. Okay, if you do not know how to calculate this, I'll tell you. You take two axes, one along x, one along y. By symmetry, Ix and Iy will be same. Okay, so moment of inertia about an axis passing through the intersection of these two, Ix and Iy, that is at the center of the square plate, would be Iz, or you can call it as ICM. This will be equal to Ix plus Iy from perpendicular axis theorem, which is 2 times Ix, and the moment of inertia about any of the axes, either x or y, will be given by ma square by 12. Okay, this is a standard value, so we get ma square by 6. So we know the moment of inertia about the center of mass. Now for application of parallel axis theorem, we should know the distance of the new axis from the center of mass. Now if this is a, this will be a by root 2. Okay, so applying parallel axis theorem, I will be given by ICM plus mx square, where x square is e by root 2. So if we substitute the values, ma square by 6 plus ma by root 2 whole square, we will get ma square by 6 plus ma square by 2, the value of which will be 2 ma square by 3. Okay, so the correct option is option D.